Specific heat capacity. You have learned in the last lesson that the temperature rise of a cup of water is directly proportional to the time of heating. And you have also done this question, which tells you that the temperature rise is inversely proportional to the mass of water being heated. Now we may put the two results together so that we may have the following result. That is, the temperature rise will be directly proportional to the amount of energy provided, but inversely proportional to the mass of water being heated. And in this way, we may rearrange it so that we may have this result. That is, Q over M over delta T should be a constant. And that constant, we call it specific heat capacity. To make it easier, let's explain this. That the specific capacity of water is 4,200 joule per degree Celsius per kilogram. And what it means? It means that for 1 kilogram of water, when its temperature increases by 1 degree Celsius, then it should absorb 4,200 joules of energy. That's the meaning of specific heat capacity of water. And now what happens if it is a cup of 2 kilograms of water and the temperature decreases by 4 degrees Celsius? We may do simple calculation to see that the water releases 2 times 4 times 4,200 joules of energy. And of course, different materials, they have different specific heat capacity. And the specific capacity of water is comparatively high when compared with that of those other materials, which means water have to absorb quite a lot of energy so that its temperature may rise a little bit. On the other hand, if you look at those of metals such as copper, it absorbs such a small amount of energy and then its temperature may rise more easily. By the way, we only talk about specific capacity of pure materials, but for combined materials, then we have to use heat capacity instead. Heat capacity is what you have learned last time. Examples include electric kettle. An electric kettle may consist of a metal body with a plastic handle. In that case, it is not pure substance, so we use heat capacity for electric kettle instead. In the next lesson, you will do an experiment in groups to find the specific capacity of water. We know that the specific capacity of water is something like 4,200 joule per degree Celsius per kilogram. But then, in an experiment, it is not easy to find this value accurately. And so you are going to do it yourself and then try to find out how you may find a more accurate result and how to explain any difference between your result with the standard value. Your book lists the steps to do the experiment. What you have to do is to find the initial temperature and joule meter reading. The joule meter will tell you how much energy is transferred to the cup of water. Now you then turn on the heater until the temperature rises by about 8 degrees Celsius. Keep stirring the water so that there is a uniform temperature distribution. Lastly, turn off the heater and measure the maximum temperature of water. That will be the final temperature, T2. And also mark the final joule meter reading, J2. In this way, you may calculate the specific capacity of water by using the following formula, where Q is the amount of energy transferred to the cup of water, so it would be J2 minus J1. And delta T is the temperature rise of the water, so it would be T2 minus T1. And so you get the formula to find the specific heat capacity of water. And the unit of specific capacity of water should be Joule per kilogram per degree Celsius. And now let's watch the video and see how the experiment should be done.
Fill 0.2 kg of cold water into a polystyrene cup and place an immersion heater and a thermometer in the cup. Record the initial temperature of water and the reading of the Joule meter. Switch on the heater. While heating the water, stir it continuously. When the temperature of water has risen by about 10 degrees Celsius, switch off the heater. Continue stirring the water and record the highest temperature reached. Record the final Joule meter reading.
In a real experiment, it is common to find that the experimental value is larger than the standard value. The reason being that there is energy loss to the surroundings, which include the energy loss to the surrounding air, as well as the energy to heat up the polystyrene cup, the stirrer, and the thermometer. And due to the energy loss to the surroundings, the experimental value is found to be greater than the actual value. So, if you are asked to repeat the experiment to get a more accurate result, what will you do? Now here is a suggestion. Suppose the room temperature is T. We may heat up the cup of water from T minus 4 to T plus 4. In this way, there will be heat gain from the surroundings in the first half of the experiment. And then there will be heat loss to the surroundings in the second half. And they will balance each other. In this way, the heat exchange with the surroundings is reduced. And that's all for the preparation. Would you do question 68, 69, as well as the question on the next page, which is question 70, before the next lesson?